Hello everyone, welcome. So now we will be looking at one more random variable, that is binomial random variable. If you are following my lecture series, then you must have seen that we have already introduced binomial probability and you know what kind of experiment we deal with. So in binomial probability we have experiment that have outcome with two possibilities: success, failure, head, tail, and we ask the question that what will be the probability of having k success, or if we talk in terms of the coin tossing experiment, then we ask question that what will be the probability of that you will get k heads, right? Now since we have introduced this random variable, we will look one step ahead and we will map those outcome of those experiment to some real number. And who will do that? Any random variable will do that, and that random variable will be called as the binomial random variable. Okay, so what kind of experiment we are going to deal with? Experiment will have an independent trial. If we take an example, we will be tossing coin n times and all those toss of coins are independent. So we will have such kind of experiment where we will be doing an independent tosses of coin, and let's suppose that getting the probability at each individual trial, getting the probability of head at each individual trial is p. Then what will be the getting of probability of tail? That will be 1 minus p, right? So that is the one point about the experiment. And so what will be the sample space for this case? Let's say we toss the coin for 3 times. We do the toss for 3 times. What will be the sample space? Since we are tossing a coin for 3 times, we will have total possible outcome. Maybe we will get the head at the first, we will get head at the second, and maybe again we will get the head. So we will have to just list down all the possible outcome. So that will be your sample space. Let me list down all those possibility. So this is your sample space. Now we define a random variable, that is x. And what will be the input to this random variable? The input to this random variable will be any of these outcome. We will carry out the experiment, and let's suppose this is the outcome of an experiment. Then we will give it to random variable, and random variable will do mapping according to some predefined rule or some according to his own functionality. So this information you will be given in the question itself. You will not have to worry about this. So how this random variable is mapping to all these outcome? So we have how we have defined this random variable. X is the number of heads observed. So let's suppose we carry out the experiment and we get this as an outcome. We toss the coin for the first time, we get the head. Again we toss the coin for second time, again we get the head, and again we toss the coin for third time, we get the head. So we done the our trial for 3 times and we have got this as an outcome. So this will go to the as an input to this random variable, and according to our mapping, how this will map, how this random variable will map this outcome to a real line, that it says that number of the heads observed. So you see how many head we have observed? 3 head. So random variable x will map this to, let's say, 3. Now maybe we will again carry out the experiment, and let's say at the first trial we get the head, and again at the second trial we get the tail, and at the third trial we get the tail. So we carry out the experiment and we did toss the coin 3 times independently, and let's say we get this outcome. Then this will go to the random variable and it will map according to whatever his mapping functionality. So it says that number of the head observed. So we have observed here total number of 2 heads, so this will map to here on 2. Similarly we can do for all these possible outcome, and we will see that where these are getting mapped by this random variable x. So once you are done with this mapping, you get to know that what are the possible value that random variable x can take. So random variable x can take 0, 1, 2 or 3. These are the possible value that this binomial random variable can take. And why we are calling this random variable as a binomial random variable? Because of the nature of the experiment. What is the nature of the experiment? The nature of the experiment that we are carrying out an independent trials, and out of an independent trial we will have some success and we will have some failure, or in terms of coin tossing model we will have some heads and we will have some tail. So overall point is that we will have an independent trials, and in an independent trial we will have 2 possible outcome, that is success, failure, or maybe head or tail, right? And we will have this probability that of getting success is p, or in terms of coin tossing model probability of getting head is p. So the experiment is completely specified in terms of 2 parameter, that is number of trials, that how many independent tosses we are doing, and what's the probability of getting head at each trial. Okay, so now we have our random variable. Now we can find the PMF of this binomial random variable. So instead of finding the complete probability, like probability of what will be the probability that this random variable will get 0 or 1 or 2 or 3, let's do for only 1. So what will be the probability that random variable will take the value 2, right? So this is the PMF notation, and if we have to write this same notation in terms of our traditional probability, how we can write that probability that random variable this x will take the value 2. So this particular event corresponds to what? So x is taking the value 2. So this particular event corresponds to getting 2 heads in 3 trials. So 2 heads here we can get, here and here, right? So these are the possible outcome which will give you 2 heads. Now if I am asking that probability that random variable will take this value 2, that means either this event would had happened, head, tail, or maybe this event would had happened, or maybe this event. So if we find the probability of all these events and add up to this probability, then we will be getting the probability, what will be the probability that random variable will take the value 2. All these So what's the probability of this event? So that will p square 1 minus p. And similarly we have two heads and one tail, so plus p square into 1 minus p plus p square into 1 minus p, right? So that will be 3 times p square 1 minus p. And recall from our binomial probability, that is same as 3 choose 2 times p square 1 minus p. So if we have to write this, the formula for the in general formula for this binomial probability, we have already seen this in binomial probability, right? So that will be, let me write that what will be the probability of getting k heads or k success, that will be n choose k probability of getting success k times, and since we have done n trials, so we will have one probability that we will get n minus k times failure, right? So in this formula, it is the probability of obtaining k success in a sequence of n independent trial. The only thing is that it is the only thing here new is that instead of using the traditional probability notation, we are now using the PMF notation. So in general, binomial random variable can be used to model any kind of situation in which we have a fixed number of independent trial and identical trial, and each trial can result in success or failure, and we have a probability of success that is equal to p. The number of success obtained in this trial is random and it is modeled by a binomial random variable. Now it will be interesting to look at few of the plots. Let's look at, so let's first of all focus on this. So what we are doing, we are tossing a coin for 3 times, and we are assuming that our coin is unbiased coin. That means getting a head or tail is equally probable, and getting that head, the probability of getting the head is 0.5. So as you can see in this example, so what we have here on the plot, on the y-axis we are showing the probability that a random variable can take, and on the x-axis we have the values. Like for this example, the random variable x can take 0, 1, 2, 3, 4, 3, right? 0, 1, 2, 3. So what we are observing here, our coin is unbiased. That means we have 50% chance that we will get the head and 50% chance that we will get the tail. We are doing this trial for 3 times. So what will be the probability that you will get the 3 times head, and what will be the probability that you will get 2 times head in a 3 trial? Which is more likely? Obviously, if our coin is unbiased and have the 50% chance to get a head, and if we have to compare the likelihoodness of 2 event, the first event where we are saying that we are getting 3 consecutive head, and the second we are saying that in 3 trials we are getting the 2 heads, which is more likely? So getting the 2 heads out of 3 trials is more likely than getting a 3 consecutive head on our 3 trial, right? So even if you see that random variable will take the value random variable that take the value 1, right? So if you see the associated event of this particular, where this random variable is taking the value 2, what are those events? What are those outcomes? So these are the favorable outcome that is favoring this event, right? So 3 outcome out of 8 is favoring this event, right? And if I say that what will be the probability that out of 3 trials we will get 1 head, so that is also more likely to happen than getting the 3 heads, or right? Because if we are doing the 3 trials, if we are tossing a coin 3 times and we have given that coin is unbiased, that means we have 50% chance. And if we are saying that what will be the probability that we will get one head, so intuitively you can say that it is more likely than getting 3 consecutive heads, right? And if you even look at the sample space, and if you look at the corresponding event where random variable is taking the value 1, what does it mean that random variable is taking the value 1? It means that out of 3 trials we are getting, what will the probability that we will get one head? So this event corresponds to these 3 events, right? Here we are getting one head, and one head. So again, out of 8 we are getting 3 elements that are favoring our event, right? And if I talk about the event where random variable is taking the value 0, 0 means we are saying that there will be no head, all the trial outcome will be tail. So that will be less likely if we are saying our coin is unbiased, right? And if we are saying that if we are tossing a coin for 3 times, then how likely that we will get none of the head? It would be less likely than other outcomes, right? So if you look at the plot, what will be the probability that you will get one head and what will be the probability that you will get 2 heads are almost equally likely, but getting the 3 tail or getting the 3 consecutive head are less likely than these 2 events, right? Our coin is unbiased. I think it should make sense to you. Now let's suppose we, instead of doing 3 times, let's do it for 10 times, and again our coin is unbiased. That means there is 50% chance of getting head and 50% chance of getting tail. So if I tell you that what will be the probability, or if I ask you that what will be the probability that we will get 5 heads, that would be more likely, right, than other events. Because if our coin is unbiased, that means there is 50% chance of getting head and 50% chance of getting tail. Then if we do the trials for 10 times, then most likely we will end up with the 4 heads or 5 heads, something like that, or 6 head, right? So that is why these events where random variable is taking the value 4, 5 or 6 have kind of more likely than other events, right? Here what we are saying that we are getting 2 heads. What will the probability that out of 10 trials we will get 2 heads with given coin that is unbiased? So that will be, you can say, getting 2 heads out of 10 will be not too much likely, right? Because we have a coin that tells you that you have the 50% chance to get head, and you are doing a trial for 10 times. So obviously there would be more likely that you will get more than 2 heads, right? Now let's again increase our number of trials, right? And again our coin is unbiased, and if we say that what is more likely to happen, or if we ask that what is more likely to happen, that so out of 100 trials, if our coin is unbiased, then almost 40 to 60% times we will get the head because our coin is unbiased, and beyond that there would be less probability, less likelihoodness of getting the head, right? So we can think like this. Let's suppose that we are tossing a coin for 100 times. Then if I ask you that what will be the probability that out of 100 times you will get 100 heads, so your coin is unbiased, and so that would be almost impossible, right? If your coin is unbiased, and if your trial is 400 times, and if I ask you that what will the probability that out of 100 trials you will get the 100 hits, that will be like impossible. So least likely. Similarly, if I ask you that what will be the probability that you will get the 0 hits out of 100 trials, that is even least likely, right? But in one sense, if I say you that out of 100 trials you will get 40 to 60 times head, then I can say yes, they can have like more likelihoodness of occurring, right? Now let's understood this plot. So in this plot, what we are trying to see is that we have now biased coin, and this probability shows that what will be the probability that you will get a head in one trial. So we are doing it for again 3 times. We are tossing the coin for 3 times, but now we have changed the coin. Now our coin is biased coin. That means 20% of the time you will get the head, and 80% of the time, 80% of the chances that you will get the tail, and 20% chance that you will get the head. So if you flip this coin, or if you toss this coin for 3 times, then since coin is a biased coin, so and it says that you have the only 20% chance to get the head. So if we are doing it for 3 times, then obviously we will have the like if I say that you will get the 0 heads, so that would be like more likely to happen. Why? Because we have only 20% chance to get the head. So yes, it could be case that we can get only tail, because tail has the higher probability of getting right, because that have the 80% chance. If you toss the coin, there is 80% chance that tail will occur. So you can say that getting the head is difficult in this case, and what will the probability that you will get the head 0 times out of 3 trials? So that will be more likely, right? And similarly, if you ask that what will be the chance that you will get the 2 heads out of 3 trials when your coin is biased coin, that would be less likely, right? Similarly, again, you have a coin that is biased coin and it says that 20% of chance that you will get the head. Then out of 10 trials, maybe, so where the likelihoodness is more. So you can say that there is, if I say that what will be the probability that you will get the 2 heads if this is the situation, that would be more likely, right? Because yeah, with the coin of this kind where we have the 20% chance to get the head, and if you're doing it this trial for 10 times, then yes, 2 head is like more likely to happen than other trials, than other events. If I say that you will get the 6 head out of this 10 trial where you have the coin that is biased coin, and the probability of getting head is only 20%, then getting the 6 times head out of these 10 trials will be not too much likely, right? And if we, let's suppose if we have a coin that have only 10% of chance of getting head, and if we are doing the event for 100 number of times, then if I say you what will be the probability that you will get the 100 heads if you have 10% of chance getting head in a single trial? That would be like impossible, even like very less likely to happen, right? But if I say you that you will get 1 or you will get 10 heads if you have this kind of situation, you are doing this trial for 100 number of times and getting the probability at each trial have the 10% chance, and out of 100 trial, if I say you that you will get the 10 head, then what's the probability that getting the 10 head would be more likely than getting other events, right? So yeah, that is it.